Well, kids, sorry, I don't know what I've caught, but it caught me. So, yesterday we did something very important for logarithms. You have to understand what we did, or you can't do logarithms. The first thing was that the bottom part of a power is the index of the radical to be taken. So that if that's a 2, that means I have to take the square root of the base at some point in this problem. So 16 to the 1/2 power means 4. So if I said 8 to the 3rd power, that would be the cube root of 8, which is 2. If I said 32 to the 2/5, that would mean at some point I have to take the 5th root, then I have to square it. So the 5th root of 32 is 2. 2 squared is 4. Yeah, it's working. Oh, sorry. Didn't think it was working there for a minute. So 16 to the 3/4 means take the 4th root of 16, then cube it. The 4th root of 16 is 2. There's 4 2's in 16. And then 2 cubed is 8. So if I had 8 to the negative 2/3, there's 3 parts to every power. The bottom is the index of the radical. In this case, 3 means cube root. The top is what we normally think of a power. Then if it's negative, it means flip it. Positive means leave it alone. So the cube root of 8 is 2. 2 squared is 4. And negative 1 means flip it. So do this one for me, my students. 27 to the negative 2/3. So the 3 on the bottom means take the cube root. Cube root of 27 is 3. The 2 means square it. 3 squared is 9. And negative means flip it. So what would this be? 100 to the negative 3/2. So the 2 means take the square root. The square root of 100 is 10. 10 cubed is 1,000. And the negative means flip it, so it'd be 1 over 1,000. Now, if the bases are the same and they are equal, the only way that could be true is the powers are also equal. Now, we do have some exclusions. Can't use 1 because 1 to the 2nd power is the same as 1/3. 1 to the 3rd power. Can't use 0. And don't use negatives. And we'll talk more about that in a couple days. So if I have 2 to the x equals 2 to the 4th, you would say, okay, x has to be 4 because the bases are the same, so the powers are the same. So if I have 4 to the x equals 8, what I want to do is get the same base on both sides. So this would be 2 to the 2x equals 2 cubed. So 2x equals 3, x equals 3 halves. So if I had 8 to the x equals 16 to the x plus 1, I'd say 8 is 2 cubed, so it'd be 2 cubed to the x. 16 is 2 to the 4th. So I'd have 2 to the 3x equals 2 to the 4x plus 4. Because remember, when you raise a base to a power, then raise it to another power, you multiply the powers. So you'd have 3x equals 4x plus 4. So subtract 4x, and then take the opposite of both sides. So see if you can do one on your own. 27 to the 2x equals 81 to the x plus 1. So go ahead and try to do it. So this would be 3 cubed to the 2x equals 3 to the 4th to the x plus 1. So it'd be 3 to the 6x equals 3 to the 4x plus 4. So 6x equals 4x plus 4. 2x equals 4. So divide by 2x equals 2. So for my freshman, I'm going to put this in Schoology. I want you to do it. For my 8th graders, you can look right off the screen and write them down. And then do them for homework. You can freeze the video, So, like I said, for my freshmen, it would be in Schoology. I know my 8th graders, you don't get to Schoology, but anyways. There's your assignment for today. Sorry, can't be there. I don't know what happened. I felt great until about 6 o'clock. Thank you.